Hey, this is Tony Scott. We're going to be going through the 2011 AP Calc free response number 2. So, as a pot of tea cools, the temperature of the tea is modeled by a differentiable function h for 0 is less than or equal to t, which is less than or equal to 10. Where time t is measured in minutes and temperature h of t is measured in degrees Celsius. Values of h of t and selected values of time t are shown in the table above. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. So to calculate the rate at which temperature of the tea is changing, we're going to have to find the slope between the 2 points. So you do that by doing f of b minus f of a over b minus a. So that's going to be 52, so f of 5, 52, minus f of 2, 60, over 5 minus 2, which gives you negative 8/3 degrees Celsius per minute. So that means that every minute the tea is getting 8/3 degrees Celsius colder. Part B, the equation represents the average temperature in degrees Celsius of the tea over the interval from 0 to 10 minutes. So, in order to estimate that using a trapezoidal sum, you're going to do 1/10 and then multiply that by base 1 plus base 2 over 2 times the height. So for the first one, it's base 1, 66 plus 60 over 2 times the height, which in this case is 2 because the interval is from 0 to 2. Then it's going to be 3 because it's from 2 to 5, and 60 plus 52 over 2. And then the next one's going to be 4 because it's 5 to 9, so it's 52 plus 44 over 2 times 4, right here. And the next one's only 1 because it's from 9 to 10, so it's 44 plus 43 over 2 times 1. So when you do that, you'll get 126 plus 168 plus 192 plus 435 over 10, which gives you 52.95 degrees Celsius. This means, and that represents the temperature, the average temperature over the whole interval. In part C, the integral from 0 to 10 of h prime of t dt is just h of 10 minus h of 0, which is 43 minus 66. So that's going to give you negative 23 degrees Celsius. And that represents the total change in temperature of the tea in degrees Celsius over the interval from 0 to 10 minutes. So the tea cooled 23 degrees over the first 10 minutes. And now on to part D. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by a differentiable function b, for which it is known that b prime of t equals negative 13.84 e to the negative 0.173 t. Using the given model of time t equals 10, how much cooler are the biscuits than the tea? So to find this, you're going to calculate the integral from 0 to 10 of b prime of t dt, which is the same thing as the integral from 0 to 10 of negative 13.84 e to the negative 0.173 dt, but that represents the total change in temperature of the biscuits. And that's going to give you negative 65.817. So to calculate the temp of the biscuits, you're going to do 100 plus the integral from 0 to 10 of b prime of t dt. So 100 minus 65.817 is going to give you 34.183 degrees Celsius, which is the temperature of the biscuits at time t equals 10. To find the difference between the biscuits and the tea, the temperature of the tea, 43, minus the temperature of the biscuits, 34.183, is going to give you that the biscuits are 8.817 degrees Celsius cooler than the tea. So I hope that helps, and thanks for listening.